Hi, I'm Abe, and today we're going to be deriving kinematic equations. Fun. Alright, let's first start with the equations that we have. We have acceleration, and we have velocity. The ones that we're going to derive are change in displacement, final velocity, and an equation that does not include the variable for time. Acceleration is change in velocity over time, and velocity is change in position over time. Now we obviously can't keep these 5 over here, because where are we going to do our work, right? So let's just put them in our little corner, so we have them there for whenever we need them. Now to derive our first equation. But before that, let's take a closer look at these. We need to know what the assumptions are behind these equations so that we can work with them properly. Math is just quantified logic, and if we mess up the logic, the answers are going to be wrong too. So these first two assume velocity to be constant, and the 3 that we're going to derive assume acceleration to be constant. When we derive these equations, we're going to have to keep that in mind. Now, you keep that in mind until later, when we're going to do that. So our first equation is change in displacement. I realize there's a bit of a glare there, that's why I'm going to write them here. So the way that we actually figure this out is using a graph. Now, that graph has time on the x-axis and velocity on the y-axis. This graph, just like this equation, assumes acceleration to be constant. So our velocity is going to be increasing constantly, like that. This area right here is our displacement. So put that x there. So the question is, how do we find the displacement? This is a trapezoid, right? So it's not like we can just find the area by time times velocity, unless we can. There's a complicated way where you could find the area of this triangle and then find the area of this square / rectangle. But we're going to do the easy way. That is using the average velocity. We need to make this slant straight. And in order to do that, we need to know what that point is, because that's going to be the velocity for that. That point is the average velocity of all of these velocities over the time. That's how we put this guy over here into that little hole. Then we're going to have a rectangle, and we can just multiply time times velocity. Now what we did to get that line was average the velocities. So that's why we have this. We found the average, the final velocity and the initial velocity, and then we multiply this by time to get this area, which is displacement. Our second equation, the equation for final velocity, is actually the most simple to find out of all 3 equations. It's just math. So we get our acceleration equation and we start to move things around. Now, change in velocity is final velocity minus initial velocity over delta time, change in time. Now, if we multiply both sides by delta time, we get a delta time equals final velocity minus initial velocity, of course. If we just add initial velocity to both sides, then we get our equation. Final velocity equals initial velocity plus acceleration times change in time. And that's that. And now, last but not least, is our third equation, the one that does not have time. So mathematically, we would want to cancel time, right? Cancel delta time. So let's use acceleration to solve for time. Multiply both sides by delta v, then divide both sides by acceleration. Get delta v over acceleration. Now, because this has acceleration, we can only put it back into equations that don't have acceleration. And the one equation we see is this. Change in displacement. Now, change in displacement is this. Times delta t. We plug that in for delta t, and we get this. Vf plus Vi over 2 times Vf minus Vi over A. Vf minus Vi is change in velocity, final minus initial. So then we see that this is a difference of squares. So we really have Vf squared minus Vi squared over 2A, which equals change in displacement. Now, from getting there to there isn't much of a stretch. Here, D stands for displacement, which is this. So we just multiply both sides by 2A, and then add Vi squared to both sides, and we end up with the third equation. Mathemagic, isn't it? Now, I hope that video was helpful and you enjoyed it. Good luck on your kinematic adventures.